Hi there, this is Thermophysics Lesson 9. This is Average Molecular Kinetic Energy exam style questions. So you can have a go at this one if you wish, you can try and figure it out, or you can let me take you through it. But either way, I'm going to go through the answers now. So please pause if required. Calculate the RMS speed of nitrogen molecules at 30 degrees Celsius. So to calculate the RMS speed, we're going to use kinetic energy is a half mv squared, essentially. Or you could call it half mc bar squared. Either way, it's the same equation. So what we need the mass and the energy. So let's get the energy first. So the energy is simply 3/2 kT. So 1.5 times Boltzmann's constant, 1.38 times 10 to the minus 23. Multiplied by the absolute temperature, so it's 30 degrees Celsius, so we need to add 273 Kelvin. So we've got 303 for the temperature, so that gives a kinetic energy that's equal to 6.27 times 10 to the minus 21 joules of energy. And then next we need to find the mass. So we've got the energy. So if you've not done this, we need to write this down somewhere. The complete number is 6.2721, just in case for further subsequent calculations. So let's clear this. Now let's find the mass of a single 14 nitrogen molecule. So it's got mass number 14. So we need to do 14 grams, 14 times 10 to the minus 3, and divide by Avogadro's number. That should be 6.022. So apologies. Either or, if you've used any of those, you will get the exact same answer essentially. In an examination on the AQA specification, for example, it's only given to 6.02 anyway, so it doesn't really matter. So let's do this first of all. 14 times 10 to the minus 3 divided by Avogadro's number. 2.32 times 10 to the minus 26 kilos. So we've got the mass and we've also got the kinetic energy previously. So now we can calculate the RMS speed. So we're going to use energy is equal to a half mc bar squared. So we arrange to get C. So C bar is equal to 2 times the kinetic energy divided by the mass of an individual atom, and then square root. So let's do that now. So we've got 2 times the energy. So it's 6.2721 times 10 to the power minus 21 divided by the mass, which we just calculated, 2.32 times 10 to the minus 26, and then square root to give the average speed, which is 735 meters per second. So hopefully you got that right. If not, I hope you now understand the method in how to complete a question such as this. So let's try another one. So let's pause and have a go. Calculate the mean kinetic energy of air molecules at 0 degrees Celsius. And use this answer to calculate the RMS speed of the O2 and CO2 molecules. And the molar masses of 32 grams and 44 grams are given there. So let's go. So first of all, let's find the kinetic energy. Kinetic energy is 3/2 kT. So that's 1.5 multiplied by K, Boltzmann's constant, 1.38 times 10 to the minus 23, multiplied by absolute temperature 273, which gives us a kinetic energy of 5.6511 times 10 to the minus 21 joules. Then what we should do is find the mass of each molecule. So we've got the energy, so make sure this is written down, or if it's correct, just tick it. Then let's find the mass. Let's do the O2. So the O2's mass will be the 32 grams, so 32 times 10 to the minus 3 divided by Avogadro's number. Either or 6.023 or 22 times 10 to the 23 equals, so that gives a mass for the O2 of 5.31 times 10 to the minus 26 kilos. Then for the CO2, the molar mass, so 44 grams, 44 times 10 to the minus 3 divided by Avogadro's number yet again. That gives a mass of 7.31 times 10 to the minus 26 kilos. So we've got the energy of each molecule now, and we've got the mass of each molecule. Now we just need to use the kinetic energies half m c bar squared or half mv squared to find the respective speeds. So equation wise, I'll just write this down. So it's half m c bar squared. So c bar squared, or c bar, is equal to 2 times the energy divided by the mass, square rooted. Okay, that's what we're going to use. So let's make some substitutions. I'm going to do O2 first. So we've got speed is 2 times energy divided by the mass, square rooted. So 2 times the energy, which we got earlier, is 5.6511 times 10 to the minus 21 divided by the mass, which we calculated for O2, 5.31 times 10 to the minus 26, and then square root. And that gives a velocity, or speed actually, should I say, c bar, which equals 461 meters per second. And then on the right hand side, same equation. Let's do CO2. So it's 2 times the energy. So again, 2 times the 5.6511 times 10 to the minus 21 divided by the mass, which we calculated to be 7.31 times 10 to the minus 26, and then square root. And that will give us an RMS speed, which is equal to 393 meters per second. Hopefully that's helped. If you get this type of question in an exam, it can be worth quite a lot of marks. And that's the technique, that's how we do it. So I hope that's helped. Thanks for watching, and I'll speak to you soon.